Page 2 of discrete random variables. Math HL addendum. So number 3, a random variable x has a probability distribution given by this expression here for x equals 0, 1, 2, and 3. Find the probability for x equals 0, 1, 2, and 3 and display the results in table form. Okay, so let's see. We're going to have a table with the different x values, 0, 1, 2, and 3. And each one of these is going to correspond to a probability of it happening. So the way we're going to calculate it is using this formula here. So maybe we could do this with a calculator. So since I need to calculate 4 of these values, I'm going to do it using y equals. So I'm going to put in this formula, and I'm going to use x for x, and x is going to vary from 0, 1, 2, and 3 in the table. Let me show you how I'm going to do that. First, I'm going to go to math because I want to get the combinations function. 3 chooses x. So I go to math, and then I go to probability, and then I go down to and chooses r. Okay, before I do n chooses r, I'm going to type 3. A little bit easier if I do it that way. So first I'm going to type 3. Then I'm going to math. You don't have to do this if you have a newer calculator because you can just like move your cursor into it, just put it in the right place. X. Okay, and then I'm going to multiply that. Oh, maybe I should put parentheses around it. Second, insert parentheses. And then I'm going to multiply that times 0.4 to the x. So 0.4 to the x. And then I press right arrow, and then I'm going to put 0.6. Enter. To the 3 minus x. And then I'm going to look at the table, second table. Okay, and there we go. So these are all the values. First one is 0.216. Second one is 0.432. And the third one is 0.288. And the fourth one is 0.064. Okay? All right. Find the mean and standard deviation for the distribution. So now we're going to add these 4 numbers together and then divide by 4 to find the mean. That's pretty easy, right? So let's see. We could do that with stat calc, okay, or stat edit. But just so that we can see how to do it, I'm going to write it out, okay? So the first one for mean, the mean is equal to 0.216. Oh, I'm sorry. The mean would be 0 times 0.216. Okay, I'm taking the x value and I'm weighting it using the probability. 1 times 0.432. And then 2 times 0.288. And 3 times 0.064. And that is equal to, okay. Let me just show you how to do this on the calculator now that I set it up. So if you get this on the exam, by writing this out, then you could get, partial credit even if the calculator doesn't work out. Okay? So I'm going to put in the numbers here. I'm going to put 0, 1, 2, 3. And then over here, I'm going to put 0.216, 0.432, 0.288, oops, 0.288, 0.064. Okay, and then, oops. Yeah, and then we're going to go to stat calc. So we got stat edit, we put those in, right? We go to stat calc, and we're going to do one of our stats, and we're going to make the frequency list L2. The way we do that is we look around for L2. It's right here. So we do blue 2, and then we go to calculate. And that gives us that the mean is 1.2. 1.2. Okay. What about standard deviation for the distribution? The standard deviation for the distribution, let's go grab a formula for that. It's actually this formula here. Okay, so we're going to add up the weighted random variables squared, and then subtract out the average squared. Okay, so let's do that first. We are going to, so instead of, it looks very similar, so I'm going to just like borrow this. Put it here. Okay. And then I'm going to erase the mu because it's no longer mu. Now it's going to be sigma. And as part of sigma, I need to put a square root sign over it. Okay. And then instead of 0, I'm going to put 0 squared. Instead of 1, I'm going to put 1 squared. Instead of 2, I'm going to put 2 squared. Instead of 3, I'm going to put 3 squared. And then, at the very end, I'm going to subtract mu 1.2 squared. Okay? So that is this formula here, right? I put the 1.2 squared there, I subtracted it, and then I added up all the 0 squared, 1 squared, 2 squared with the weighted probability there, and then I put square root over the whole thing. So that's it, right? So, but the calculator already gives us this, okay? It's right here. It's 0.848, 0.849 actually, okay? But you could do it without the stat function just by adding these up and taking the square root, okay? Let's see if there is no variance, right? Yeah. So if you wanted variance, you just square that. Okay? Alright, next go to the next one, number 5. A random variable x has a probability distribution shown. Copy and complete. Okay, so let's look at the table and see if we can fill, or let's look at the graph and see if we can fill the table. So this first one is 0.1. And the second one is 0.2. Third one is 0.4. The fourth one is 0.2. The fifth one is 0.1. Okay. Find the mean and standard deviation sigma for the distribution. Okay. Basically, you have two choices. One is to write these equations out, and the other is to just use the calculator. Okay. If you're going to write the equations out, basically what you're going to do for me is you're going to multiply 1 times 0.1 and 2 times 0.2 and so on, right? And for standard deviation, you're going to have square root, and you're going to have 1 squared times 0.1 plus 2 squared times 0.2 plus dot, 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 and you're going to subtract out, in the last position, you're going to subtract out the mean squared. Okay? So let's find out what the mean is in this case. We'll just use the calculator to do the actual calculation. So it's going to be 1, 2, 3, 4, 5, and in the probabilities, we're going to put 0.1, 0.2, 0.4, 0.2, 0.1. Okay, and let's do stat calc. 1-bar stats. Calculate. So our mean is 3. And our sigma is 1.0 or 1.10. Okay? Alright, C. Determine the probability that x is between mu minus sigma and mu plus sigma. Well, let's find out what mu minus sigma and mu plus sigma are. Mu minus sigma is equal to 1.9, right? It's 3 minus 1.1. Mu plus sigma is 4.1. Okay? So what's the probability that's within that? Okay, so 1.9, the 1.9 border is there, the 4.1 border is here. So basically what we're saying here is that the probability that we get 2, 3, or 4. The probability that we get 2 is 0.2. The probability that we get 3 is 0.4, and the probability that we get 4 is 0.2. So the answer for this is 0.8. What about the next one? What is the probability that's between mu minus 2 sigma and mu plus 2 sigma? So that would be mu minus 2 sigma is equal to 3 minus 2.2. 3 minus 2.2 is 0.8. And mu plus 2 sigma is equal to 3 plus 2.2, which is 5.2. So for this one, we're talking about between here and here. So that's the whole thing. So the probability of that happening is 1, because it includes all the green bars, which add up to 1. Okay? Let's go to 7. When a pair of dice is rolled, the random variable m is the larger of the two numbers that are shown uppermost, or the value of a single die if a double is thrown. So in table form, record the probability distribution of m. So I made this table or this grid to show like what they mean by this. So you're going to roll 2 dice, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So every time you roll both dice, the score that you're going to consider is the highest die roll between the two. So like, for example, if you roll 2 1s, it's a 1. If you roll a 3 and a 2, the high roll is a 3, right? So basically, it becomes this grid here. So, and then they want us to make a table which says how often 1, 2, 3, 4, 5, 6 come up, okay? In this case, the total probability of one of these happenings is P, or the total number of occurrences that can happen here is 36, right? So if I count, like, for example, I want to know how often 6s are rolled. So that would be all these 6s here. There's 6, 7, 8, 9, 10, 11 6s here. So there's a chance of 11 out of 36 to come up 6, right? And then 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, it would be 9 out of 36, for example. Okay? And for 4, it would be 1, 2, 3, 4, 5, 6, 7 out of 36. See what I'm doing here? So when I count the 3s, I count 1, 2, 3, 4, 5. So it would be 5 out of 36. And for the 2s, it would be 3 out of 36. And for the 1s, it would be 1 out of 36. So there's the table that they wanted. They wanted a table which shows the probability distribution of m. Let me change this. It's not x, that's m, right? For the m distribution, find the mode, the median, and the mean. Okay. So the mode, remember, is the one that you learned in first grade. it's the one that most frequently occurs. It's the one you can figure out just by looking at the graph. So if I look at this, a first grader can look at this and say, oh, this is the mode because it's got the tallest column. What's the mode? It's 3. Okay? So let's do that here. We don't even need the graph. We could just look at a table. If we look at a table, we can see that the highest probability or frequency is here. And it's 1136 is the frequency, but the data that is going to yield a probability of 1136 is 6. So my mode is 6. What's the median? Okay, the median is when you have half of the data above and half the data below. Well, how many occurrences total? 36. What's half the occurrences? 18. So if I count from the top down and try to find out where 18 of the 36 occurs, it would be, I think, about here. Okay? If I count from the bottom to see when do I get to the 18th occurrence, it would be here. Do you see that the 18th occurrence is here? Okay? So if I count from the bottom, the 18th occurrence is at the very top of the 5s, right? So the median would be 5. What about the mean? The mean we would get by multiplying 1 times 136 and add it to 2 times 336 and add it to 1536, etc., etc., etc. So the way we could write it out would be, it would be 136 plus 636 plus 1536 plus 2836 plus 4536 plus 6636. Okay? So what would that be? Let's add these numbers up. I'm just going to do that on a regular screen. 1 plus 6 plus 15 plus 28 plus 45 plus 66, 161 divided by 36, 4.47. So it's 161 divided by 36, which is equal to 4.47. Last thing, standard deviation. Standard deviation. Oh, well, I guess I'm going to finally have to use the calculator. Use the stat edit function. So I'm going to put 1 divided by 36 on top. The next one, I'm putting these numbers here. So 1 divided by 36, 3 divided by 36, 5 divided by 36, 7 divided by 36, 9 divided by 36, and 11 divided by 36. And then I'm going to do stat calc, 1 bar stats, calculate, and my mean is 4.47 like we calculated by hand, and my sigma is 1.40. Okay, so my sigma is 1.40. Okay, all right. Now, to finish off this page, what are the properties of the expected value of the random variable x and the variance of x? So, the expected value of the constant k, which means, so like, if you have a random variable that always gives you the same number, like 3, 3, 3, 3, 3, 3, 3, what's the expected value of that random variable? It's 3, of course, or k, okay? What if you have a random variable, x, and it gets multiplied always by a constant? How is that related to the random variable for the expected value of the random variable itself? Well, it would be multiplied times that value of k. Okay? So if, like, for example, I have had a dice, a die, and I was always tripling its value. So instead of being 1 through 6, it always comes out to be 3 through 18. The expected value for a die is 3.5, right? The value that's exactly in the middle of 1, 2, 3, 4, 5, 6. So the expected value for tripling that should be 3.5 times 3. Okay. The expected value for A plus B is the expected value of A plus the expected value for B. Okay, for functions A and B. Okay, what about, and that's for the functions A and B. What about the variance of x, which is equal to the expected value of x squared minus the average or the mean squared? There's a couple other ways to write this. Another way to write it is the expected value of x squared minus the expected value of x squared. So when I say the expected value of x squared, the squared is around the whole thing. And to make that clear, let me put parentheses around it. Okay? And of course, there's kind of like the original definition, which would be the expected value of x minus mu squared. Okay? What about the expected value of a constant times the random variable plus another constant? Okay, so that would be a times the expected value of x, which is very similar to this rule right there, right? Plus the expected value of b. The expected value of b is like this rule here. The expected value of b is b, right? Okay? And last of all, what is the variance of the same random variable? So, you know, the funny thing about variance is if you keep adding, like let's say that I have a dice, and every time I roll it, I add 3 to it. So like instead of 6, I get 6 plus 3. Instead of 2, I get 6 plus 3. That changes the mean roll, right? The mean roll is going to be 3 higher. But if you think about it, the variance, which is like the distance from the center of the distribution, is not going to change. Just because you shifted 3 to the right, instead of getting 1 through 6, you're always going to get 4 through 9. So the width of the distribution is the same, so the variance does not depend on the shift of b. So when you do a variance of ax plus b, the only thing that affects the variance is the a. And remember, you're squaring the values, so the variance is going to be affected by the square of a. Okay, so we're going to get a squared times the expected value of x squared minus, or x minus mu squared. Or we could say a squared times the variance of x.